In this video, we are going to revise nuclear technology. Hello everyone, welcome to the Tapasya for IS YouTube channel. So let's begin. Nuclear technology. Harnessing energy from atomic nuclei is called nuclear technology. What is fission reaction? Splitting atoms, example uranium 235 used in power plants. Fusion, merging atoms, example hydrogen isotopes. Experimental propulsion. Key applications: power generation, medicine, cancer therapy, diagnostics, agriculture, food preservation, pest control, industry, material testing. India's nuclear vision. Peaceful uses. Dr. Homi Bhabha's founding principle. Self-reliance from mining to waste management. Dual use. Civilian energy and military deterrence. Doctrine. No first use, NFU. Credible minimum deterrence. CMD. India's nuclear program. Milestones and goal. Initiation in the year 1948 under AEC, DAE and BARC, formed in the year 1954. Timeline 1956 Apsara, India's first research reactor. 1974 Smiling Buddha, Pokhran first. Peaceful nuclear explosion. 1987 NPCIL established for power plant. 1998 Operation Shakti, Pokhran second. India becomes nuclear weapon state. 2008 India-US civil nuclear deal and energy waiver. Futures plans: expand capacity from 8,180 megawatt 24 reactors to 22,480 megawatt by 2030 to 32. Goal of 63,000 megawatt by 2032. Focus on fast breeder reactors and thorium-based reactors. Power generations and energy mix. Current capacity 8,180 megawatt, nearly 2% of total electricity. Contributions: provides stable base load power, complements intermittent renewables. Climate goals: nuclear power produces no greenhouse gas emissions. Key for net zero by 2070 target. Efficiency: more land efficient than solar and wind. Key power plants: PSWRS, Tarapur, Rawatbhatta, Kakarpada, Narora and Kaiga. LWRS, Kundakulam with Russian assistance. FVR, prototype fast breeder reactor, PFVR at Kalpakkam. Reactor types: pressurized heavy water reactor, PSWRS. Fuel: natural uranium. Moderator coolant, heavy water, D2O. Advantages: indigenous technology does not require uranium enrichment. Most of India's reactors are PSWRS. Light water reactor, LWRS. Fuel enriched uranium. Moderator coolant, light water, S2O. Example: Kondakulam nuclear power plant. Fast breeder reactor, FVRS. Fuel: plutonium 239 and uranium 238. Coolant: liquid sodium. Functions: breeds more fissile material than it consumes. Key to stage 2. Researchers reactor, Apsara Dhruv Cyrus. 3-stage nuclear power program. Architect Homi Bhabha. Objective: to utilize India's thorium resource for long-term energy security. Stage 1 PSWRS uses natural uranium, produces electricity and plutonium, Pu 239. Stage 2 FVRS uses plutonium from stage 1, breeds more plutonium and converts thorium to uranium 233, uranium 233. Stage 3 thorium reactors uses uranium 233 to generate power. The final stage for sustainable energy using thorium. Thorium as a nuclear fuel reserves. India has the largest thorium reserves in the world 1.07 million tons. Process thorium-232 is converted to fissile uranium-233. Advantages: abundant long-term energy source for India. Proliferation resistance: uranium-233 is difficult to weaponize, less waste, produces less long life. Radioactive waste. Disadvantages: needs a starter fuel. Thorium is a fertile material, not fissile. It needs plutonium or uranium 235 to initiate the reaction. Technically complex. The fuel cycle is complex and requires advanced research and development. Long time frame. Large scale deployment is still decade away. Key organizations: DAE, PEX body under Prime Minister; ARB, Safety Regulator; BRC, Primary Research and Development Center; NPCIL operates power plant; Bhavini operates FBRs; UCIL uranium mining. Non-proliferation and disarmament. NPD 1968. India is non-signatory due to its discriminatory nature. CTBD 1996. India has not signed, linking its signature to global disarmament. India's stance: support universal disarmament, but views nuclear weapons as a necessary deterrent for self-defense. International regimes. India is a member of export control regime like MTCR, Wassenaar Arrangement, and Australia Grove. India's nuclear doctrine. Core principle: credible minimum deterrence. CMD: a survivable arsenal to deter an attack. No first use. Will not use nuclear weapons first. Massive retaliation in response to nuclear, biological, chemical attack. Command structure: Nuclear Command Authority, headed by Prime Minister. Nuclear triad: ability to launch from land, missile, air, bombers, and sea, INS Arihant submarine. Challenges and conclusion: high cost, long construction timelines, nuclear waste management, public safety concerns, and liability issues. Civil liability for Nuclear Damage Act 2010. Conclusion: nuclear technology is crucial for India's energy security, climate goals, and strategic autonomy. The program is driven by self-reliant approach and is managed with commitment to responsible use and safety. This is the end of the lecture. So friends, we will meet in the next video. If you have any doubt, you can ask in comment section. Subscribe the channel, like the video, and don't forget to press bell icon so that UPSC focused videos keep reaching you. Thanks for watching. Jai Hind.